In this tutorial you will learn how to use Piling Tools plugin for Grasshopper with different types of surface divisions such as rectangular, diagonal, triangular, and also how to distribute different kind of geometries along reference surface. Enjoy! Hi guys, Lazar here from How to Rhino. Welcome back to our channel. Many of you asked to create a tutorial about Piling Tools for Grasshopper. So in this video you will learn how to create this surface on the right using Grasshopper only, and how to divide and distribute different kinds of geometries along the surface. If you stay until the end of this video, you will discover how you can get this definition for free. Before jumping into today's tutorial, I would like to invite you to subscribe to our channel if this is your first time watching, as we upload new video every week. It will help us to make this channel even better. And also, if you are interested in having more detailed and structured approach how to learn Rhino and Grasshopper, I invite you to apply for our Rhino for Architects course, first link in the description. So let's see what this tutorial is all about. First, as I mentioned in the beginning of this tutorial, I will learn you how to create this kind of surface. So I will close this floating viewport for now, and I will go to shaded mode and turn off this one. So first we'll create a point, and it will use as a origin of the XY plane, and using this plane we'll create the rectangle. Let's say something like this, and using this rectangle we'll convert it to a surface. Alright, and now using component divide surface we'll get the grid of points along the surface, 31 points along Y and 31 points along V direction, because if you divide in 30 divisions you will have 31 points. This is the first set of points. Another set of points will be the, let's call them attractors, and it will be the corner of the curve or the corner of the surface. And using these four, I will turn off this, and using these 4 points we will find the average, and average should be in the middle of the surface, and these 5 points will be the attractors. We'll have them here. And now we'll use pull point in order to find the distance between each of the grid point to its closest attractor point. So it will automatically calculate the distance to its closest attractor point. That's why we have here 961 values, and also we have here 961 points. Alright, I can visualize these distances by connecting these two guys. So here we have the lines where its length represent the distance, this one. These values I'm going to remap to the domain 0 to 1, and once we have these values from 0 to 1, we will use graph mapper in order to remap them based on this curve. I use the Bezier curve, and once we have remapped values from 0 to 1, we are going to again remap them to new values. So basically the line with the largest distance will be moved along Z direction for 9.6, and the lines with the smallest distance will stay in the same position because we set here to 0. So these values, once we remap, we connect with the Z vector, and this point we're going to move along that direction, and we get something like this. If you want, if you don't like this shape, you can adjust this graph mapper or choose another type of curve. Here you can go to graph types. I will keep this for now, and using these points we can create a surface, and we can do this by surface from points component. And what is really important to set here x plus 1, because here we have 30 divisions, but as I mentioned in the beginning, if you have 30 divisions you will have 31 points. So here we will set expression x plus 1 and connect with u. U represents a number of points in u direction. If you remember, here we have in u 31 points. Alright. Here I created 8 points. On each of these points I'm going to move this surface. And now these 8 surfaces we'll use for our divisions using Piling Tools. So the first component I'm going to show you, it's called surface domain number. So it's quite similar to divide surface. Basically, we're going to divide the surface along U 9 times and along V 17 times, and we'll get something like this. As I mentioned, it's similar to divide surface, but we get different result because using this component from the paneling tools, the points will be, I would say, more equally distributed along the surface. And now using this grid of points with the generate surface, we can create the panel at each of these cells. I forgot to mention that surface domain number component, it's located in the grid panel. And the generate surface is located in the panel 2D. So these points we connect with the same input GD, so that it represents the grid. PS, it means how the lines of this panel will look like, either straight, or we're going to pull them on the surface, or it will use the ISO curve on the surface, or it will find the shortest distance between them. So I choose to use straight lines, and S we should connect with the reference surface. And if we turn this on, we'll get these rectangular panels. Here we can change the vision if you want. And also here we can change, if you don't like these straight lines, we can use, let's say, ISO, it's number 2. And you can see that this grid, these panels follow the surface. And the next type is based on the attractors. So first we'll create the grid, and also using attractor point we can adjust the grid. Now let me show you. Now we'll use point attractor. Again, we will find the grid points on the surface. In between these two components, we'll add point attractor. And point attractor is located in the grid attractors panel. So in the grid we connect this grid which we got from the surface domain number. And in the A we should place the point, which will be the attractor. So that point we can get them by evaluating surface, set here a parameterized, and the EUV input will place the MD slider, and here is the point. And that point will connect with the A with the attractor. For the point attractor component, I will turn this off. And in the M we'll set the value for how much we want to adjust the grid. I will turn this on, I will turn off, and you can see how the grid is modified. If we change this slider, it will be even more modified. So if the value is positive, then the points will be basically closer to the attractor point, or if it's a negative value, then the grid points will be moved away from the attractor point. Alright, I will set back to, let's say, 2.8, and again generate surface, but this time you can notice that I didn't use base surface, so you don't need to use it every time. So basically grid connects with the grid input, and in the PS I set to straight. I will turn off, and this guy I will turn on, and you can see how the grid is generated based on the attractor point. The next method is curve attractor. Instead of using just one point, we'll use the curve as an attractor to modify the grid. Again, we'll use the surface and find these points on the surface, and basically this grid will connect with the curve attractor. So the curve attractor component, it's placed also in the grid attractors, it's here. And in the A, instead of using point, we'll use the curve. I choose this method. So basically I add ISO curve component, and with the MD slider we can extract U and V curve based on the UV point on the surface. And don't forget to reparameterize here, right click on the S input and check reparameterize. And you can see how we have now these 2 points along U and along V direction. We can use some of these too, let's say along U. And this curve will be used as a curve attractor. That's why we'll connect with A, and again in the M we'll set the value for how much we want this grid to be modified. And let's turn this on, and because we set here minus 3.95, the grid points are moved away from the curve attractor. And again, as we have in the previous example, grid will connect with the generate face with the grid input, and the PS we can set again straight and get something like this. The next example is how we can create the diamond panels. It's very easy. We need to have the surface using surface domain number. You don't need to use surface domain number. You can use some of these here, or you can divide surface based on the shore distance, or surface domain based on length, or surface parameter. So these different types of surface division you can choose, but every time I use a surface domain number. And once we have these points, we can just simply connect this grid with the component convert to diamond, and this component is placed in the grid utility panel. And once we connect grid with the convert to diamond, we will get different kind of distribution of the points along the surface, and same logic, grid of points will connect with the generate face. I will turn off this. And if you want to have more panels, you can change these sliders and this one as well. Quick announcement, guys, please put a comment in the section down below, and 5 most creative ones will get project files for free. In the next 4 examples, I will show you why paneling tools is so powerful, because you will be able to create your own shape of the panel based on the point position in the grid. Let me explain you. Again, we will use the same shape of the surface, and we'll use surface domain number to create the grid. Probably the most important part to understand is how we can create our own panels, or the shape of the panels. I will use simple example with the triangles. So we need to add component. It's called panel connection, and it's placed in the panel 2D panel. This one. All right, so here we have 4 inputs: grid, SI, SJ, and PN. In the grid, we will connect with the grid from the surface, as in the previous examples. In the SI and SJ represent how big the panel will be based on the grid. So let's go here and see what is the branch 0. I will explain you why we need this. Just to create this one, item, okay. So this is branch 0. These numbers represent I value. So this direction, it's I value, and this direction, it's J value. So I values represent the index number inside the branch. In the branch, let's say this is branch 0. This is the value of the I. It's 0, 1, 2, 3, 4, etc. So this is the I values, and the values for the J will be the index of the branches. So this is branch 0, this is branch 1, this is branch 2, 3, 4, and so on. So this is really important to understand. If we set here 1, 1, it means the size of the grid will be 1 by 1. If we set, let's say, here 1 and here 2, so it will be something like this. This big the panel will be if we set here 1. If we set, let's say, 2 and 2, the size of the panel will be something like this. So once you learn how to create the panel size based on the grid, now we'll focus on the pattern which defines the shape of the panels inside the grid, inside each cell. Is this part here. Let's see the number of branches. Okay, this is branch 0. and this is index 0. I will sketch here for this certain example. This is index 0, 1, 2, 3, 4, 5, 6, 7, and these are the index of the branches. So this is 1, 2, 3, 4, 5, 6, 7, 8, and so on. So this is I, and this is J, this is direction, and this direction. Now we'll focus on the shape of the panel. And the first point within the grid, this is the size of the grid. And the first point will be 0, 0. This is 0, 0. It means the first number represents I value and the second number represents J value. Here you can see again, as I is the item index, as J is the branch index. So this is the first point. The second point will be 0, 1. It means index of the item will still be 0, so I is 0, but the number of branch will be 1, so it's this point. The third point will be 1, 1, so I is 1, J is 1, so it's this point, and again we'll multiply the first point in order to have closed panel, and we'll get something like this. It means the next panel will have the same shape, something like this. And again like this, and so on. Let's turn on, and you can see our panels. If we want to fill this gap, we need to create another pattern for the panels. Again, the same logic. Grid goes in the grid input. Si and Sj will be 1 because we want to have panel 1 by 1, but the pattern will be different. Here we have the 1, 1. This is I, this is J. So this is 1, 1. This is 0, 0, sorry. This point will be 1, 0 because I is 1, J is 0. We have this line. Then we'll have 1, 1. This is 1, 1. And again we will have the first point 0, 0. So basically our pattern will look like this: 0, 0, 1, 0, 1, 1, and 0, 0. And you can see it here. Alright, I will turn this on. So now you learn how you can create your own panels. Well, this is a very basic example. Now I will show you a little bit more complex. First I'm going to show you the final result. Let's go step by step how to create this. So basically you can see that here we have, again, this part is the same. So basically this part is the same as in the previous example. You can see if we compare these two, but every second part is different. So this part is different, this part is different, and this part is different. So basically we have two types of panels. So the size of the panel will not be anymore 1 by 1, it will be 2 by 1. Along J will be 1, you can see here, but along I will be 2. And let me explain you why. This is the size of each panel, and you can see that this panel is multiplied along the surface. So basically here we have 1 and we have 2. The first part of the panel we will create this guy. This is multiplied along J. Here we can see we have this gap, and again it's multiplied here because here we set 2, not 1 anymore, and it's multiplied here and here. So the most important thing is to focus on the panel, and panel is this one, and inside each panel we have different types of triangles. Let me explain you step by step. I will skip this for now. First we will turn on the grid points, and let's create the first panel. Here, as I said, it's I direction, it's J direction, but this is just in this case. It can be flipped, it can be reversed. Every time it's important to see the index 0 and the branch 0. We want to create this triangle first. As we know, that our panel will have this shape. That's why we create along SI2 and along SJ1. Here we have 2 and 1. Now we need to create this first triangle. It will have coordinates 0, 0, 0, 1, 1, 1, and 0, 0. You can check it here. Alright, the next triangle will have coordinates 0, 0, 1, 0, 1, 1, 0, 0. So okay, let's check 0, 0, 1, 0, 1, 1, 0, 0. Okay, and we have this guy. Let's see what we got with the first two triangles. Okay, we have something like this. Now we need to fill this gap. Let's create another two types of the panels. This shape first. This triangle has coordinates. This is I, this is J. It has coordinates 1, 0, 2, 0, 1, 1, 1, 0. You can double check it's this guy, and it will be multiplied. Last one has coordinates 2, 0, 2, 1, 1, 1, 2, 0. It doesn't matter the order. You can start as I write it here: 1, 1, 2, 1, 2, 0, 1, 1. Doesn't matter the order. It's just important to create this panel. And if we turn on the final, we can see we created a shape like this. All right, and I will get back to this component. It's called random attraction. It's also the component from the grid attractors panel. You can find it here, random attraction. Basically, it will randomly move grid points based on the value you set here with the slider. Right now it's set to 0, but if we change to, let's say, to 1, maybe this is too much, let's say 0.2. Okay, we can a little bit randomize this grid. Maybe let's change to 0.4. Okay, so if you insert in between these two steps a random attraction component, you can basically randomize position of the grid points. Okay, I will keep it as it is for now, and let's move on the next method, how we can create 3D panels. So basically in this case we'll create the truss structure. Instead of having 2 points or 2 coordinates, we'll have 3 coordinates, because we'll have 3D panels in this case. Okay, we'll start with the surface. Again, surface domain number, and create grid points. This is the grid 1. The grid 2 will extract the center point of each panel, and you can find these points by adding component center grid, which is placed in the grid utility. Just connect grid with a center grid input, and in the S you can place the surface. Green color points are the centers of each of this grid. The next thing, we will move them along normal vector. In the vector we can get adding component coordinates. Component is placed in the grid utility. It's called the coordinates, this one. And we need to connect grid with the grid input and S with the reference surface. We will get these 3 outputs. Basically the point on the grid and these 3 vectors along X, Y, and Z. We need Z vector because we want to move them along Z vector. Here we can set the amplitude. Let's say we want to move these center points along Z vector for the value of 3. Z vectors actually in this case represent the normal vector on the surface, and we will move them something like this. So this will be the grid 2. Here we have grid 1, and here we have grid 2. In order to create 3D panels, so 3D connected panels, we will add a component called panel 3D connections. It's placed in the panel 3D panel the last one. In the grid 1, as I mentioned, we'll place the initial grid, and in the grid 2 we'll place the center grid or center points of the grid moved along normal vector, so this one. As in the previous example, we need to define the size of the grid. We'll keep it as 1 by 1, and in the pattern we need to create the 3D panels. Okay, let's focus just on this one. We want to create, this is the center moved along normal vector, and we want to create something like this. So this will be the panel sample, and that panel sample will be distributed along the surface at each grid cell. Okay, it means that we need 4 different surfaces. Let's create the first one. First one will be this guy. Coordinate of the first one will be 0, 0, 0. This one will be, because this is I direction, this is J. This one will have the coordinates 1, 0, 0. And this one will have the coordinate 0, 0, 1. Always we'll keep these first coordinates 0 for the next grid generation. Basically, this point has the coordinates 0, 0, 1. Okay. 0, 0, 0, 1, 0, 0, 0, 0, 1, and 0, 0, 0. It's this one. Okay. The next one, let's say, can be this guy. This one has coordinate 0, 0, 0, 0, 1, 0, because J it's right now 0, I is 0, J is 1. So we have these two, and the third one is 0, 0, 1, and the first point will be multiplied. Okay, is this guy. So the same logic we'll use for the other two segments of the panel. Again, let's create this one and this one. First, I will create the right one. It will have coordinates 1, 0, 0, 1, 1, 0, and this one is 0, 0, 1. Okay, let's check. It's this guy. And the last one will have coordinates. Let's start from this one. 0, 1, 0, 1, 1, 0, 0, 0, 1. And it's this guy. Okay, once we create these panels, I will turn this off. We got something like this. Here we have W represent the lines, C represent the polyline cells, and M represent this mesh. So we'll use these lines and connect with the pipe, set the pipe radius 0.1, and here we can see how we easily created truss. Let's disable this because it takes 3.5 seconds. If you change this slider, you can add even more panels if you want. Or if you change this slider, you can move the center points along normal vectors based on this slider. Okay, if you like this result, you can again enable this component and it will preview these lines as a pipe. Okay, I'll turn off this. Alright guys, and the last example for this tutorial will be how you can distribute different kind of geometry along the surface. I will turn off and turn on the surface. Same again, find the grid points on the surface, and once we have grid points, we need somehow to add the thickness to that grid. Basically, we'll use these points with the component coordinates, the same as we used in the previous example. We'll take these grids and move them along normal vector on the surface. Here we can set the value, and this will be the thickness of our grid. If you want in another direction, you can easily just reverse this vector. Let's say reverse vector. Okay. and here you can add, let's say, 2. Okay, using component Morph 3D, it is located in the panel 3D. This one, we will place the grid 1, which is our original grid. Grid 2 will place the grid moved along normal vector, and we need the weight. It should be the values from 0 to 1. If you set just 0 and connect here, you will get just one panel here. So that's why you need to have multiple numbers, and these weight numbers you can get by random attraction. Probably there is another way how you can get this weight of each of these grid. I use this one, so use this grid and connect with the random attraction. For the M or for the magnitude I set 0, and here we have the weight values, and this weight will connect with W input of the Morph 3D list component. Okay, here we set the size. SI and SJ will be 1, and the last thing is to define what kind of shape you want to distribute. I already created a shape like this, and this shape we should connect in the PO input. Once we connect, let's see what we got. I'll turn this off, and we have something like this. If you want another kind of shape, you can play with this. Maybe you can try this one. So I will set here from 0 to 1. Basically, you can create some pre-geometry which you want to distribute along the surface, and just that shape you should connect with the PO input. It's very similar to the original Morph from the Grasshopper. And once you have this, you can add, let's say, more panels, and in another direction as well. It takes time to calculate it. I will set it back to the previous shape. As I mentioned, it takes time to calculate this. Alright guys, if you like this video and would like to see more of this, please consider to subscribe and like this tutorial, as we upload new video each week. If you want to have project files of this video, you can supporting us on Patreon page. I would like to say special thanks for all our Patreon supporters. It really helps us to create even better and more valuable content for you. And one more thing, if you are interested to see another method how you can divide a surface, I recommend you to watch our tutorial about Lunchbox plugin. Until next time, take care and see you soon.